So hello everyone again and welcome to my channel. So this we're going to continue from where we stopped related to Lewis structures, and Lewis structures has evolved over a couple of years, and it's quite interesting how we need to be able to understand this concept in organic chemistry. We focus more on interaction between two atoms or adjacent atoms in terms of one pair of electrons. One pair of electrons between two atoms leads to bonding pairs, and bonding pairs we saw examples of those, which includes alkane. An alkane, or I will just say carbon-carbon bond, which is just one bond. And now we're going to focus on multiple bonding system. Now, multiple bonding system involves the sharing of more than one bonding pair of electrons. So this includes stuffs like two pairs of electrons that are being shared between two adjacent atoms, which leads to the formation of double bonds, and others which includes three pairs of electrons which are being shared, forming a triple bond. Now, this concept involves various examples. Let's take for an example. For a two-pair electron sharing which forms double bond, a very simple case is the formation of ethylene. Now, this is kind of an old word, but you know what? We're just going to make it a much more simpler form that you're more familiar with, which is ethane. Now, ethane has a molecular formula of C2H4, and if you want to draw the Lewis structure of this particular compound, what you need to realize is that if you have two carbon atoms, both having 4 electrons each, now these 4 electrons are positioned around here, and then you note that there are 4 hydrogen atoms, each containing 1 electron. So if I add the 4 electrons evenly, I get this. Now, if I then introduce the dash, then dash represents bonding pairs. So what I get by introducing the dash is a H dash dash with the C dash H with the C dash H. And that leads to just one more thing remaining. We have these unpaired electrons over here that are split between the two carbons. Well, what happens then is that once they come together by a form of an overlap, that leads to the double bond between the two carbon atoms, forming ethene. So this is the structure for ethene. Pretty much I can say the Lewis structure of ethene overall. So other forms of double bonds include the formation of carbon double bonded with oxygen, with 2 lone pairs on the oxygen, and then hydrogen and hydrogen. This particular compound here is called formaldehyde. And another form of this between carbon and nitrogen involves a double bond between carbon and nitrogen with a lone pair on nitrogen, and a nitrogen-hydrogen bond will lead to the formation of formaldehyde. This is an M, and this is an N. So one thing you need to note here is that for carbons, you see here that we have 4 bonding pairs with no lone pairs on the carbons. Now as you move from carbon to nitrogen, we change from 4 bonding pairs to 3 bonding pairs, including 1 lone pair. And last and foremost, if we're going from carbon to nitrogen to carbon and oxygen, we introduce 2 bonding pairs and 2 lone pairs. So that is about it for double bond. Now for the 3 pair electron system, which forms triple bond, a typical example of that is ethylene. Ethine. Now ethine is also called acetylene. Now acetylene is kind of an old name for it, but anyways, it's really combustible when in the presence of oxygen, and it's kind of a dangerous gas overall, so kind of be careful while handling this particular gas. But anyways, this guy over here has a molecular formula of C2H2, and if you're trying to draw the Lewis structure, what you realize is that carbon as usual has 4 electrons, but now you're including hydrogen, just 2 hydrogens evenly shared between the 2 carbon atoms. Now once you introduce dash, what you realize is that you have a dash between the carbon and carbon, and a dash between each of the carbons and hydrogens over there. So what you're left with is 2 lone pairs, or I would say 2 unpaired electrons between each carbon atoms. And what you form then is you have an overlap of electrons over here and overlap of electrons over here, thereby generating bonding pairs. This leads to the formation of a triple bond between the carbon atoms, and this is actually the molecular structure of acetylene. So some couple of examples of this includes dimethylacetylene. So di means you have 2 methyl groups shared between the 2 triple bond dead carbons, which is that over here. So this is called dimethylacetylene. And another example will be acetyl nitrile. So an example of that would be, this is it over here. With its lone pair on the nitrogen over here. So you see here that the nitrogen here is neutral, and that is similar to this nitrogen over here, which is neutral with just 3 bonds surrounding the nitrogen and 1 lone pair. And the same thing applies to oxygen, which is neutral as well, and this carbon, which is neutral as well. But anyways guys, that's about it for this particular lecture. One thing you have to actually note also is that the formation of 4 bonds surrounding carbon, they call it tetravalent. Then for nitrogen is called trivalent because it has 3 bonding pairs surrounding the nitrogen. Then oxygen is called divalent. And last and foremost, if you're looking at hydrogen or halogens, we call them monovalent. So that's about it for this particular lecture. Thank you so much for watching this, and please don't forget to hit the like button, share and subscribe. Next video I'll be showing you a couple of examples and some problem solving strategy enough for you to understand how to distribute atoms or electrons within multiple bonding systems overall. Thanks again for watching. Please don't forget to hit the like button, share and subscribe. Have a good day. Peace, love you all, and be smart.